When adding and subtracting rational expressions, we need to follow the same rules we would do for adding and subtracting fractions, which we need a common denominator. On example 17, our denominators are both 3x. So what that means is I can add my numerators, 5 plus 7, to get 12, and I keep my denominator the same, just like I would if I were adding or subtracting fractions. Then I can simplify if possible. 3 can go into 12 4 times, so that would make my final answer 4 over x. If I were asked for excluded values, I'd make sure I look back at my original before I simplified or added to show my excluded values, which is that x cannot equal 0. On example 18, since I'm subtracting and I have common denominators, that means the denominator of my answer is going to be x minus 1. It does not change. When I subtract, I just need to make sure that I'm subtracting this entire numerator. It's almost as if it were in parentheses, which might be helpful to you to remind yourself to subtract both pieces. So 3x minus x would be 2x, and then minus 5 would be negative 5 or minus 5, for my final answer of 2x minus 5 over x minus 1. And in this case, my only excluded value would be 1. You can try examples 19 through 22 on your own and check your answers on the answer key. Adding and subtracting rational expressions gets a little bit more complicated when you don't have a common denominator. So remember that if you had, say, 2 over 721 plus 3 over 648, the quickest way to find a common denominator, it might not be the least common denominator, would be to multiply the two denominators together. So I could multiply this one by 648, and remember that whatever you do to the bottom, you're going to have to do to the top. And I could multiply this one by 721, top and bottom. So that would give me a number that would be the common denominator between the two. There might be a smaller one, but it's probably just going to be faster to use that one. So on example 23 and 24, I just want to find my common denominator. So I'm going to focus first on my numbers, 4 and 10, then I'll focus on my r's. So the first number I can think of that I can get 4 and 10 to create by multiplying is 20. So that would mean that I have to multiply this by 5, top and bottom, and this by 2, top and bottom. And then I also see that this has r squared, which means r times r, and this only has r to the first power. So on the left fraction, I'm also going to multiply top and bottom by 5r. That's going to make my least common denominator 20r squared. Now when we change our fractions or rational expressions to actually add or subtract them, when I multiply the numerator by that number, I would want to make sure that I'm distributing it through. Or I could leave it in factored form, which might actually be easier. On example 24, this is a little different because they're not monomial denominators. They're going to be products of binomials, or maybe binomials and monomials. So x minus 3 squared means that x minus 3 is multiplying itself twice, so I can expand that out to look like this. And then I could also factor x squared minus x minus 6 into x minus 3 times x minus 2. So I can see that this denominator is made up of two x minus 3's. This denominator has one of those, but it also has an x minus 2. So what I'm going to do on this denominator is I'm going to multiply by x minus 2, which is the part of the denominator that the red one has that the blue one does not. Now when I get to the adding and subtracting, I'd want to do that on the top as well, x minus 2. And then my red denominator is missing one of my x minus 3's. So I would multiply by x minus 3, and then on the top by x minus 3. It's not going to make sense to multiply these in like FOIL and distribute. I'm just going to leave my denominator in factored form. So try these adding and subtracting examples, and when you're ready to check your answers, head over to the answer key.